Okay, so before we start with the different indicators, the different metrics, it's important to keep in mind that the mean, the median, and the mode are all valid measures of central tendency, but under different conditions, some of them are better than others. So this is something very important to keep in mind. We always tend to use the mean as the best indicator to derive or to calculate the central tendency of a mean of a population, but sometimes it's not enough as a central tendency indicator. Okay, or sometimes we need more than one, or sometimes we need to choose another one because the mean is not always the most appropriate, and we'll see why. Okay, so anyway, going to the mathematics, the mathematics are very simple here. I'm sure you already know what a mean is, but the mean is basically the rate, the division between the sum of all the elements of a population or a sample divided by the number of elements. So if we have or a class of individuals and we're going to calculate the mean age, we need to sum the age of each individual. Imagine we have 16 individuals and then divide this sum by 16. So let's do a very simple exercise now below where you have a few numbers: 12, 5, 10, 7, 12, 1, 18, 7, and 8. So you need to calculate the mean of those elements. Yeah, so let's do it quickly. I will give you some time while I also do it with the calculator. 12 plus 5 plus 10 plus 7 plus 12 plus 1 plus 18 plus 7 plus 8 equal to 80. Now divided by 1, 2, 3, 4, 5, 6, 7, 8, 9 elements. It's 8.88 is the result. Okay, this is how we calculate the mean. Now imagine that we want to calculate the mean of another data set, but where there is a number which is very extreme, an outlier, but only one. Okay, so it's basically the same data set plus one outlier. This outlier might be a mistake in the typing, or might be a mistake in the measurement, or might be a real number. Okay, but it's an outlier in any case. So if we repeat that mean, but now we add the new number, and then it's not 9 elements, it's 10 elements, the result is 208. So the question is this 208 a good representative of the second data set? Obviously not, because as you can see, most of the elements are between 0 and 20. And how can be the mean 20 times this range, the maximum? Okay, obviously because there is an outlier. Just think about that. Think about that. We'll come back to this problem or to this fact later. So, when it's not recommended to use the mean, it's very sensitive to the influence of outliers. So, in those cases, when we have outliers, we normally use the median over the mean, or even the mode sometimes. So, what is the median? The median is the middle score of a set of data that has been arranged in order of magnitude. It's less affected by the outliers and skewed data. We'll see later also what is skewed data. So, how to calculate the median? The value that represents the exact center of the data. To calculate the median, we need to set all the values in ranking order, so from smaller to bigger, and then if the odd numbers of the value, if odd numbers of values, then the median if the central value. So if we have an odd number of values, we take the median as the central one. If we have an even number of values within this population or sample, we need to take the two central values and calculate the arithmetical mean. Okay. So repeat the exercise. Just try to repeat the exercise. So according to the steps before, we need to sort all the values. We need to take the central one or the two central, if depending if we have an odd or even amount of values, and we calculate the result. Okay, just do it yourself, take your time, and compare to the results of the mean from the previous slide. What is the difference? Okay, you don't need to answer, it's just for yourself, just to try to understand why the median is more appropriated to when we have outliers in the dataset. So again, the question, what is a skewed distribution? Why do we prefer the median over the mean to represent these distributions? Okay, these are questions basically to think about at this initial stage of the lecture. The last one, the mode. The mode is basically the most frequent score in our dataset. Yeah. So if we have a sample with a few numbers, we need to count the frequency, the number of repetition, how often a number appears there, and count this repetition, and basically take the most frequent. It's not very complicated. So if we think into a histogram, basically what the mode will represent the peak of the histogram. A histogram is a graph which represents the frequency of the value. So if you see this histogram, you will see that 0 appears to almost 200 times in the population. This number, which is something like 3, appears 400, and so on, so on. So it's a graph which counts in the x-axis the number of times that this number appears, and in the y-axis the value itself. No, sorry, it's the opposite. Sorry. In the x-axis is the repetition, the number of times a value appears, and in the x-axis the value itself. Okay? Okay, let me check the time we spent. Okay, let me stop here this video, and then we continue with the with this summary of summary table for the different measures and when it's more appropriate to use each of them according to the type of data. So we continue in the slide number 29.